welcome to our video tutorial of geometry proofs, introductory geometry proofs. We're going to go through two proofs in this tutorial, one dealing primarily with line segments, the other dealing primarily with angles. Perhaps you want to hit pause and try to work ahead before we detail these proofs together. So the first thing that I like to do is identify the given in the picture. So as we look at this scenario, AB is congruent to segment DE. I'll mark those on the picture. Here's AB, here's DE. And we also know that segment AC, I'll mark those on the picture, is congruent to segment CE. I also like to put this little marking on each of those segments to indicate that they are, in fact, congruent. What we're trying to establish is that BC and CD have to be congruent when we're done. Now when I label those, I'm going to put a question mark around them because we don't know that yet. We're trying to establish that must be the case. Look and see if this visually makes sense to you. So if the two big magenta segments are congruent and the two blue pieces are congruent, should it also work out that those two want to start with the given? And although we said you can point, let's write it out. Segment AB is congruent to segment DE, that was in our given. And segment AC is congruent to segment CE. The reason on those is straightforward. They are given to us. Now secondly, we talked about this. To actually work with these items in a proof, we need equations. So we're going to transfer this notation into saying that the distance from A to B is equal to the distance from D to E, and the distance from A to C is equal to the distance from C to E. How do we know that if the line segments were congruent, their lengths were equal? Well, that's just the definition of congruent segments, which we do abbreviate a little bit. Now this whole proof is based on the idea that a part plus a part equals the whole thing. So step number 3, we're going to use the segment addition postulate. And we're going to have two equations listed that work in tandem. So on the left hand side, the vertical pieces, we've got the distance from A to B plus the distance from B to C is equal to that whole thing, the distance from A to C. Horizontally, on the bottom, now please try to line things up. So DE matches up with the AB. I'm going to say the distance from D to E plus the distance from C to D is equal to that whole segment, which is the distance from C to E. Now always keep an eye on where you want to end up. So we want to end up with BC and CD being equal. In other words, we really kind of want the right-hand side of this equation to disappear. In order to do that, we're going to replace CE. We're going to replace it with AC. So in step 4, I will rewrite the top equation exactly the way it was written. AB plus BC is equal to AC. On the second equation, I will rewrite the left-hand side identically. DE plus CD, but now we will replace the CE with an AC. It seems like a cool thing to do. And the reason we can do that is that we know since AC and CE are equal, we can use them interchangeably. That was substitution. Now step number 5. We said this in class. Listen again right here. If AB plus BC is equal to AC, and AC is equal to DE plus CD, then AB plus BC has to be equal to DE plus CD. Or another way of saying that is the following. If this, look at what I'm circling, is equal to AC, and AC is equal to that, then this has to be equal to that. We called that the transitive property, and we said that would pop up a lot in geometry proofs. The other way I look at it is saying if the two right-hand sides are equal, then the entire left-hand sides have to be equal as well. Now getting into step 6, look at where we're at, look at what we need, and again I think we're going to do a substitution. Because instead of writing DE right here, we want the AB and the DE to cancel. The only way we're going to be able to do that is if we replace the DE with an AB. So we will do that substitution. We'll have AB plus BC is equal to, now we're doing this replacing, it's going to become an AB plus CD. Again, that was substitution. Please be careful on abbreviating substitution. You don't want it to look like subtraction. Step number 7, now we're close to where we want to be. We can subtract off the AB from both sides, and we'll get that BC is equal to CD. That was just subtraction. But we're still not quite done, because we need to end up exactly how we were told to end this proof. We need to transfer it from equals into congruent, and we'll put the line segment bars on top in order to say that line segment BC is congruent to line segment CD. How do we know that? So if two line segments are equal in length, they are congruent. That is just the definition of congruent segments. I'll put a smiley face because we did that proof in its entirety. Take it step by step, piece by piece, and hopefully when you're done, it really isn't that bad. Our second proof that we are going to consider is an angle proof. And again, if you want to hit pause before we discuss it, that might be wise. Okay, so in this proof, we're given that angle AVB and angle DVE are congruent. We're trying to prove then, we want to prove then, that angle AVD is going to end up being congruent to angle BVE. Well, the key to this problem is that both of those angles overlap at BVD. So we're going to put those markings on the picture. We know AVB is the same as DVE. We're trying to establish that the two things in green are congruent. And we know that the blue items have to be congruent because they're the same thing. So again, this is going to come down to a part plus a part equals the whole thing, and a part plus the part equals the whole thing argument. Let's set up our proof, and let's try to work this one out. Again, please be mindful of some notation as we go. The first step of your proof should always be what's given. And in this case, we are given that angle AVB is congruent to angle DVE. Now, in order to do work with this, we need to convert it from angles being congruent to their measures being equal. So make sure you write the M because of measure. Measures are equal, so I'm going to put the equal sign into play as we do this. And this is going to be the measure of angle DVE. How do we know that if two angles are congruent, their measures are equal? Well, that's just the definition of congruent angles. Now, step number 3, we will break out the angle addition postulate. So the part, measure of angle AVB, plus the other part. Now look at what we have. It's the measure of angle BVD is equal to that whole thing in the top piece, which is the measure of angle AVD. And in this other piece, it would be the measure of angle DVE plus the measure of angle BVD, yet again, it's that same piece in blue, is equal to that whole green angle, which is the measure of angle BVE. Now look at where we're trying to go. We want to end up with basically the right-hand sides being the same. So we'd love to have these left-hand sides cancel. Watch this. We can replace DVE with AVB in the second equation, and we'll write everything else the same way it appears. So the top part of the equation, we're going to rewrite the same as it was, not changing anything. I'm even going to leave my color coding alone. But now instead of DVE, we're going to replace it with AVB. Everything else remains unchanged. And that was substitution. We just substituted. Now here comes that key part of this proof again. And it pops up in a lot of geometry proofs. The two left-hand sides are exactly the same. So what we're basically saying is the measure of angle AVD is equal to this, and this is equal to the measure of angle BVE. Therefore, the measure of angle AVD has to equal the measure of angle BVE. The other way of saying it, and it's going to be wordy, but if the measure of angle AVD is equal to the measure of angle AVB plus the measure of angle BVD, and the measure of angle AVB plus the measure of angle BVD is equal to the measure of angle BVE, then the measure of angle AVD has to be equal to the measure of angle BVE. That's right, it's the transitive property. And we're almost done. We need one more step. Because we can't end with the angles being equal in measure, we need to end with the angles themselves being congruent. So how do we know that if the angles are equal in measure, they are congruent? Well, that is the definition of congruent angles. Smiley face because we're done, but please watch for the structure and the process of these proofs. Please make sure you've got everything detailed as it needs to be done.